then you have the 1 minus n elasticity, 1 over elasticity.
Yeah, exactly. So you have p times 1 minus 1 over n times the elasticity, right? Exactly. And that's equal to cost, and that gives us the Lerner formula that we had from before. And this is a general formula for Cornetta competition. Okay, so if we have constant elasticity of demand, Patrick, what happens as n increases?
As n increases, it goes to 0.
Yeah, the markup is going to go to 0, right? Because as n increases, this elasticity is constant, and this markup just goes to 0. So the right-hand side, and thus the markup get driven to 0. As competition increases, price is driven to cost, and therefore the quantity is going to become the efficient quantity. So just to hammer home this point, let's consider another example. So imagine that demand is given by this form that you also looked at the problem set. So what is then going to be the equilibrium equation, Leo?
Yes.
Okay. Leo? What's going to be the, here was the equilibrium equation, what's that going to be in the case of linear demand? You can come drive it on the board if you want, or you want to come drive it on the board?
Sure.
So this was expressed in terms of price as a function of quantity. So why don't you solve for price as a function of quantity under this form first?
Drive first.
Yeah, so solve for price as a function of quantity first. Oh, but you have to, that's equal to quantity, right? So you have to put quantity on the other side. So you've got quantity is equal to this, right? So when you solve for the P, you need to include Q on this side of the equation. Right? Yeah. But then that doesn't multiply that. You're on the right track. Just make this little Q so it's not so cumbersome with the Q of P there. You can just make it a little letter Q. It's just quantity. Okay. So quantity is equal to sigma minus sigma times P over 2 m, right?
Right.
And then you can just solve for P in that equation. You've made a valiant effort. I'll let you off the hook, okay? So, right, we can just say if quantity is equal to this, right, we can multiply both sides by 2m, then we get Q times 2m is equal to sigma minus, 2m sigma minus sigma p, divide by sigma, and we get this equation here. So p is equal to 2m times 1 minus q over sigma. Then we take the derivative of price with respect to quantity, and we get negative 2m over sigma. And we know that the individual quantity of a firm is the total quantity divided by n. So we can then write out our equation from here. Price plus quantity of an individual firm times quantity prime is equal to C as 2m times 1 minus q over sigma, that's just p, times p prime, 2m over sigma times q over n is equal to c. So that's 2m times 1 minus n plus 1 q over n sigma is equal to c. And as n gets large, right, n plus 1 over n converges to 1. Right? So the left-hand side of this equation converges to 2m times 1 minus q over sigma, which is exactly p. Right? And so that converges to price is equal to cost. So again, as the number of firms increase, price is driven down to cost. Okay. So these are both examples of a more general result called Cornet's theorem. So as the number of competing firms gets arbitrarily large, price converges to marginal cost. This is one of the most fundamental results in economics, probably the most fundamental result in industrial organization. It's both the foundation of everything that we were doing about perfect competition in the first half of the term, because this is why firms act as price takers. Why price is equal to marginal cost is that all firms are a small part of the industry. And it's the basis of most antitrust and competition policy, and it holds much more broadly than the examples above. Yeah, Tejas.
I just want to make sure, so
Yeah.
from the last part, is that given that the quantity of each firm is the same? Or from those particular?
Yeah, but the firms are all the same, so it's natural that they're all going to end up having the same quantity at equilibrium. So firms can have nonlinear costs, firms can be asymmetric, and you can have a broader range of demand functions than the ones we considered. And in fact, demand can satisfy weaker regularity conditions than we impose. The key is just that eventually every firm is a small part of the industry, and this fails only in sort of silly or perverse cases. But it's also broader than Cornett competition. So it's not just true in Cornett competition. Suppose that we have Bertrand competition, but the distribution of costs, but firms have different costs. This is something we briefly considered in the other class. This could represent Bertrand competition, or it could represent an auction, right? We said that there's a very close similarity between Bertrand competition, where people have different privately known costs, and an auction. And it's going to basically be optimal for firms to set their price to just beat their competitor. That is, they set it equal to their expectation of the costs of their competitor, their closest competitor, conditional on them winning and being the lowest cost firm. So I basically bid my best guess of the second highest bid. This is literally going to be right if the firms face perfectly inelastic demand, as in an auction. There's just going to be one object sold, and it is going to be, you're going to want to bid slightly lower price in order to increase the quantity that you're able to sell if the demand is somewhat elastic. So I'm not going to go through the proof, but it's sort of pretty intuitive that I'm going to try to just beat the next guy. If I'm allowed to name my price, I want to beat him, but I don't want to be much below him, because then that's going to lower the price that I get. Okay, so if this is what people are doing, if people are bidding just enough to beat the next lowest guy, what is going to happen as the number of competing firms gets large? He-san?
Yeah.
Yeah.
So as firms come in,
Yeah.
as it goes up, yes.
Don't look at the slide. Everyone's trying to just beat
So
the
yeah,
next guy.
basically, it's the lowest.
Yeah.
So,
Why? So there's a lot of firms now.
yeah.
If I'm one firm, what am I gonna, if there's lots of other people competing, what am I gonna have to bid if I'm gonna just try to beat the next guy?
What?
You're saying your cost?
Yeah.
So why is that true?
The water cost, like if I water cost, is that, I don't know, I'm not sure.
Okay. Well, does anyone else want to try to explain what happens in Michael?
As the number of firms increases, I prefer the lowest cost out of the few will probably have like a lower cost that's there are just like two firms and you're never gonna bid below your own cost.
Yeah.
So it drives it down to where
Yeah.
your cost is.
Yeah, that's right. So basically what happens is that as there get to be more firms, right? I think there's like tons of people breathing down my neck, right? So if I want to be the best, if I want to win, I'm going to have to do very close to the best I can possibly do, which is sort of intuitive. Like in any sort of competition you have, the more people that there are out there, the more likely it is that people are going to be doing very close to as well as the best person, right? And so nobody's going to have much margin for error. Right? If you think about any athletic competition, the more people there are competing, the more that the top athlete has to give his absolute best performance, right? Because otherwise he'll be beaten by the next guy. Whereas if there's very few people, I can afford to slack off a little bit, and no one will beat me. Yeah, go ahead, Trent.
Wouldn't that run against, like, your idea of Zipf's law?
Yeah, that's a good point. So that's an extremely good point. So in Zipf's law, that's not true, but the problem is that costs are bounded from below. So the point is that Zipf's law, you can be sort of like arbitrarily more talented than the next guy, right? Whereas as the number of people gets large, there's like sort of a bound from below of where costs can go, right? So costs can't keep getting lower and lower and lower arbitrarily, right? Yeah, Eric.
So if everyone's basically just trying to beat the price of like the next guy.
Yeah.
And so obviously if there's like a large number of firms, it basically just goes to the lowest price. I mean the
Yeah.
lowest cost. But if
Yeah.
there's like a small number of firms, wouldn't it go to the second lowest cost? Like because the lowest cost guy will sell at the second lowest cost to beat that guy.
Well, it's gonna always be exactly the lowest cost guy's expectation of the second lowest cost guy's firm. That's always that's exactly what this says here.
Right.
Right. So that's what it is when there aren't that many, but as it gets larger, that's gonna drive it down towards the lowest guy's cost. So my expectation of what the second lowest cost is gonna be, given that my cost is the lowest cost, is gonna get driven towards what my cost is, and my cost is gonna get driven towards the lowest possible. The winner's cost is gonna be driven towards the lowest possible cost. And thus price eventually converges to the lowest constant marginal cost. Intuitively, as there are more firms, each individual firm is less necessary to the whole. And so again, price is gonna get driven down to cost. Yeah, real quick.
Are you talking about in terms of long run? Because in the short run, if
Yeah.
it goes down, some firms be out of business.
Yeah.
So supply would go down, prices go up.
Well, here the firms have constant marginal costs, so that's a very extreme case when, as prices come like down, all that happens is demand increases, right? Firms don't get driven out. It doesn't, yeah. Exactly. So again, we obtain in a very different sort of a situation, sort of another version of Cornetta's theorem. So as the number of firms increase, price gradually converges to the lowest constant marginal cost. If all costs were not constant marginal, then everyone would be doing different quantities, as Rokuk was suggesting. And this is going to become efficient too, because again, each firm is going to think that it can only just, go up against the next best firm. And as long as every firm is becoming a small part of the industry, that'll happen. So in a very different model, the same basic result.